what were you doing on the 18th of February 2015? Let me help you with some headline news from around the world on that day. So in the Ukraine, the missile conflict was continuing. In Istanbul, there was heavy snow that caused the airport to close. In Malaysia, the family and friends of the missing passengers on flight MH370 were protesting. In Finland, people were celebrating Chinese New Year. And right here in Amsterdam, we were celebrating a tiger going outside for the first time. Now, why is that date significant? It was the date that Mark Nottingham submitted the final request for change for HTTP2. Now, what I find a little bit ironic about those true stories from that day on some leading newspapers around the world is that there wasn't really much talk about HTTP2, and yet this is the single protocol that they rely on to get their stories out to the wider world. It was only when you started digging in a little bit more to the Guardian technical section and the BBC technical section that we started to see news about the new protocol. So my name's Michael Gidding. I'm a performance evangelist at Akamai.
Yep. My name is Javier Garza. I'm an enterprise architect and also evangelist in Akamai in Santa Clara. And today we are going to talk about HTTP2 performance, basically measurement, rendering, small files, and sprites. All right, so let's start with measurement. So we have something called real user monitoring. Akamai has one, many other companies have one, and basically you measure real devices over normal network conditions by sending a JavaScript beacon, and then that submits some metrics, and you can measure and collect it and run some statistics. And across all the Akamai customers, we have many billions of beacons. We saw good improvements and many websites, and other websites didn't do as good. And some of those websites that didn't do as good, one of the main reasons was, for example, they have a big chunk of third-party content. And the third-party content was spread over many domains, which generated extra TCP connections, and also those were not using HTTP2. So most of the third-party domains, they were using H1. The other thing that we want to give you as an advice, if you want to test HTTP2, one thing will be, how do I do it? So there are very ways of we seeing people implement it. One of them is, I'm going to turn 1 week H1 and the next week H2 and then back to H1 and see what is the difference. Other ways that people do it is they use different ways of implementing it, but the best approach that we have seen so far is doing 50% split for everybody, so that randomly a user gets either H1 or H2, and another person, maybe on the same network with the same browser, gets the other protocol. And then you can do real comparisons between browsers, the same browser, on the same network, on the same geography, and so on. So there are 3 things that change the performance on HTTP2. One is the browser, so different browsers have different implementations and perform different. The other is latency, so how far are you from the servers? And the other thing is the packet loss. Packet loss has an impact on performance, and we are going to talk about it. All right? So in this case, we have a website from a retailer in the US. This is RAM metrics. And on the orange, you have the H1. And on the blue, you have the H2. And you can see this graphic is for a wired connection, so non-mobile. You can see, but basically, both overlap. So the H2, the blue, you can see a little bit more bluish on the beginning and a little bit more on the top, but basically they are very similar. If you go to mobile connections on the other way, you can see that the big chunk of the fastest times is on H2. And the reason of this is in mobile you usually have higher latencies, and H2 is better for higher latencies. Another test that I ran during the summer while I traveled through Iceland, Germany, and Spain. I spent the whole night running web page tests to measure how the latency impacted the protocol. And I compare real latency, so connecting to a server that is far away in a specific country, simulating the latency. For example, web page test, when you run a test, you can specify the latency that you can inject into the test. And then I did a combination of tests by different browsers and protocols. So we have I think 7 different cities with latencies from 2 milliseconds, where we were in the same data center, to 211 milliseconds, which I think was Cairo, was the city that we have with the longest latency. And then we did the same test, just injecting the latency by hand with a command parameter. We repeated for Chrome and Firefox and turning H2 on and off. The reason why we choose Chrome and Firefox is because with web-based tests, you can have a parameter to turn off H2 on those two browsers, and then you can do A/B testing easily. All right? And we repeated each test 9 times, and all the combinations, and then we repeated all the combinations hundreds of times, so we have a bunch of tens of thousands of tests. So the lessons learned, I'm not going to go into all the details, but basically, you cannot trust the simulated latency. So one of the results of this test is between the same browser, for example, Chrome, H1 and H2, if you will do the difference between the real latency connected to a server far away and injecting a latency with a command line tool, it was very different. And in Chrome, it was much more different than in Firefox. In Firefox, was more similar, but still a lot of difference. So if you want to try that, don't try it out. It doesn't work very well. All right? So by browsers, it's different. So one good advice is to stick to RAM, test real user devices. One thing with RAM is you have to clean the data much more, use filters to ensure that, for example, you really compare the performance in H1 and H2 on the same browser, on the same geo, and on the same type of network. Right? How many of you attended Velocity New York from here? Nobody? Well, all right. So for those of you who attended, they had a very good talk about HTTP2. I think it was HTTP2, what nobody told you. You have, I have the link in the bottom. But basically, in that talk, they did a packet loss measurement using millions of web-based tests. And basically, the result of this is the packet loss affects the H2 performance a lot. Anybody guess why? Is one of the benefits of HTTP2 is it runs one single connection, right? The only problem is TCP starts slow, so it starts sending data slowly. And if you hit network congestion, what it does is it reduces the window size usually by half, so you can send less bytes. If you spread that over 6 connections, which is the standard for H2, you can start sending more data over 6 connections than over 1, right? So you can see the performance on the left side. You have the blue dots are H2, and the orange dots are H1. And you can see on the bottom they are faster over H2. And if you inject, when you have 2% packet loss, you can see the H2, the performance suffers, and the time increase. The same for Firefox. Firefox a little bit more constant, I would say. You see the dots more combined. But H2, if there is no packet loss, it's faster than H1. And when you inject packet loss, the TCP skews the results and make it a little bit slower. There was another very good research. This was done by the Minnesota State University and Akamai Foundry team, which is the company I work for. And basically, they use real devices, cell phones, and connect them over a cellular network to a data center on the internet far away. And basically, what they run is they run many tests and measure also the performance depending on the different networks and for different type of pages. So I was involved with this project. I set up the website for this testing. And on the left side, you can see we have a page with 365 objects, so a lot of small objects, of 2K each. So the whole page is around 700K, right? If you can see the color is hard to see, but basically the gray color is the H2, and the white color is the H1. And you can see that under normal conditions, without packet loss and a good network connection, the H2 is much faster. And you can see the other ones, if you have fair, passable, poor, is still faster. But when you have very poor network conditions, a lot of lossy networks, you can see in that case, H2 gets even faster than, H1 gets even faster than H2. On the other side, on the right side, we have the same test, but different type of content. This is a 4 megabyte page with just 10 objects. So we have 10 images, and each image is around 400K. All right, you can see that from the beginning, H1 is faster. And you can see as we increase the packet loss or the network conditions, they get worse. The difference for H1 is H1 gets faster and faster. And that's because the TCP slow start impacts a single connection when delivered more bytes. And as you have network congestion, the window size affects one single connection much more than over 6, right? So I'm going to pass it to Michael for the rendering.
So one of the things we've seen a lot with customers that turn H2 on, they just kind of turn it on, expect that magic 20% improvement. We actually see rendering get a lot worse. This is an example from the Hacker News in Chrome. And you can see in H1, it's actually better rendering than in H2. And the same is true of Firefox. And we mentioned earlier how the behavior between browsers changes, and you can see this in this slide here as well. Now, why does rendering get affected by turning on H2? Now, I like to kind of reference here and thank our American friends for probably the best export from this country that's made its way to the UK, which is Black Friday. So what happens every year on Black Friday is I sit at home in the warmth of my living room while idiots like this go shopping and fight in superstores for TVs, right? Now, why is this related to H2? Essentially, in H1, we had a beautiful queuing system where people would be allowed in the shop, 6 people at a time. They would go to the checkout, and they would buy their TVs. In H2, we kind of let these idiots all in at once, and this is what happens. And that's the same thing with our resources, is we go and download or request like maybe 10, 20, 30 resources all at once, and then those resources start competing for bandwidth. So how do we change our page, and what can we do to try and alleviate the pain of the rendering impact of H2? So the first thing is to think about your domains you're using, okay? So this is a typical kind of H1 connection. You've got your website, CSS and JavaScript all on the same domain, and you can see as we start adding more objects, we create a new connection, okay? If we move over to H1, then essentially we'd no longer have to make that same connection, okay? So there should be a win in terms of getting critical rendering content down to the browser as quickly as possible if we keep everything on the same domain. Now, for some people, that's not always possible. So let's think here about the example of a website that uses a CDN. Maybe it's Akamai, I don't know. There are other CDNs, apparently. But essentially, we've got here the website and then all the static objects. And in H1, you would see the second new connection, and then subsequent objects will then make another connection without the DNS resolution. Now, if we think about H2 in this example, if we manage to keep that connection, the second domain on the same certificate and resolving to the same IP address, then we get a little win here in that we only have to make the DNS resolution again, and the browser is clever enough to reuse that connection. If, however, we do not do this and we have separate certificates, for example, then essentially we're back at the H1 world, okay? So if we want to make sure our critical content is down as fast as possible, then we should be keeping it on the same domain. So that's all very well. Let's have a look. This is a customer website, a UK retailer. Simple, like typical setup. Main website on one domain, and then we've got the connection in here for their static content coming from the CDN. And it's a bit of a no-brainer, right? They don't have to make that second connection, and in the one below, we improve the time in the waterfall. Time in waterfall is always good, but what we're really interested in is what the impact is in the rendering to the end user. And as we can see here, we now have better rendering experience. So critical content, same domain. Another area where we can improve the user experience is with progressive JPEGs. So if we start thinking back to our Black Friday example and images, if we're suddenly requesting like 10 images, then those 10 images are all being downloaded at once, and actually their total time to download is a lot longer. And what we see with normal traditional JPEGs is this kind of window blind effect. Colleague of ours, Tobias Baldorf, did a talk in Santa Clara, like a whole talk about progressive JPEGs and H2. And if you haven't seen it before, I suggest you check it out. It's got a lot more details. But essentially, the message here is that progressive JPEGs render the full shape straight away. They have a lot more content in earlier scans, and you basically just improve the user experience of loading these images when they're taking longer to load in H2. This example here, the progressive JPEGs at the bottom were pretty much fully loaded when the other JPEGs were about 60% complete. So we had a website here, the Tesla website, and essentially this is a pretty simple page where the image makes up the page layout, essentially. But you get this horrible, it's quite a big image, it's like 200, 300 kilobytes. And you get this big image, you get the frame of nothing to start with, and then you get this horrible frame in the middle where you get half an image, and then you get the full frame. If we were to change this to a progressive JPEG, then essentially you would end up with a much better user experience and a little bit faster as well. The other area we can improve is to actually implement lazy loading. And hopefully you're kind of using lazy loading in H1 anyway. But because the browsers are only really prioritizing content by resource type, there might be more important images, for example, than others, okay? So we don't necessarily want to request all those images at once. So we could just do a little bit of lazy loading where we think about just identifying the most important images, let them be discovered normally by the browser, and then maybe hang off a JavaScript function to then go and load the secondary set of images afterwards, so that we know those first set of images are getting as much bandwidth as they need to be downloaded quickly. This is an example here of a retail site where we just had 12 thumbnails under the product image, and then all of the other product images came in the carousel behind. And essentially, by applying this, then you wait until the final thumbnail's downloaded, and then you go and get the second, third, fourth, fifth product image, because that's not the most important part of the content. We've got an example here on the Bentley website. So I was just looking for a weekend runaround car, came across this website, it wasn't loading very quickly. And essentially, they've got this one big image, which again takes up a lot of the page. And this one big image is loaded before the JavaScript and before the fonts. So essentially, the one big image starts like hogging all the bandwidth, and the other resources can't be loaded. So this is what the web page looks like when it's loading. It's like you get a flash of the image, then you get the menu, and then you get the final view on the right-hand side. So not a great user experience. And if we add in some JavaScript prioritization here, then essentially we hang the image off the back end of loading of the fonts, I think. You can see that the user experience improves. If we also throw in a progressive JPEG as well, then we get a better performance as well. So this is how we can start combining some of these operations to really improve performance. We can even take this further. So again, the benefit of doing these talks on the last day is that there's been so much great content already, we don't really have to cover a lot of it. But basically, we added on server push here. So if you were in Colin's talk a couple of hours ago, then you'll know all about it. This is an example where server push does work well, because we can send down some CSS and some fonts and improve the rendering and the performance for this site as well. So this worked pretty well in this example. Here's our waterfall. You can see on the bottom example, the CSS and the fonts being loaded while we're waiting for the HTML to be returned. And you can see the benefit in terms of like populating that opportunity there within the bandwidth. Now, as you probably learned in an earlier talk, if you attended, then this doesn't always work very well. So I decided that maybe we could apply the same thing to the Tesla website, because after all, it is just one big image that's taking up this page. And this is when pushing goes wrong, is essentially we made things slower. And the reason we made things slower is because the image was 200-300 kilobytes, and it ended up delaying the CSS and the loading of the actual HTML. So as you learned, hopefully, from Colin's talk, like pushing's good, but you've got to make sure you get it right. So wrapping up this section here then, so just to recap what we've covered, is keep your critical content on the same domain. If you do need to shard for whatever reason, whether it's balancing H1 or you use a CDN, then use the same certificate. Progressive JPEGs can help rendering. Use JavaScript if you need to delay resources and like free up a little bit of bandwidth. And then finally, use server push where you can, but be careful.
All right, thanks, Michael. All right, so we're going to continue with small files. In this case, we have a test that we did by bundling different CSS files. We disable compression to ensure we just take a look at the real bytes that are sent over the wire. And what we did is we start having 1,000 CSS into one single file. Then we split it into 5 files, well, 1,000 styles into 5 files, 15, 25, 100, etc. until 1,000. As you can see, the H2, which is the blue, you can send, you have some optimizations by means of header compression. So when you send much more files, you save some bytes, you send less bytes by the head savings that header compressions provides. But it still doesn't mean that it's faster. If we see across browsers, Most of the browsers, they do pretty good. We see the same. H2 is faster. One thing that we saw is with mobile Chrome, we saw an issue, and we are going to explain into it. So we can see H2, the performance for Chrome is better. As you deliver more files, the performance is better over H2. And you can see the difference in performance improves as you have more files, as you get 2,000 files. One thing that we saw different is in Firefox. When we did this talk in Santa Clara, I believe it was in June, we had the other way around where Firefox will do better than Chrome. Now, many releases of both browsers, the tables have turned, and in this case, Firefox didn't do as good as Chrome, but probably in a month will be different. So keep testing, and you will see. So the same thing in this case. H2 was slower, around 100 files. As you get pushing more files, it will go back faster. With mobile Safari, it was the same. If you only deliver a few files, because of the overhead, it loads much faster. But if you want to deliver a larger number of files, H2 will help. Right? So you can see the different increases with the number of files. And with mobile Chrome, we detected something really strange. We have a big gap on the load, and it was around 100 files. So when we took a look at the waterfall, we saw a big gap between requests. And when we started dig into this, we saw there is a tool called net internals. You can just type Chrome:// net internals. And then you can see the details of all the requests and the frames that go on the wire and so on. And we saw this error, which is something Kazuo mentioned today on the HTTP2 talk. We tried to push many more streams than the TCP buffer could handle, so they were stalled at some point, and that affected the loading of the page. So that's referencing to the Black Friday example. Everybody tries to get at the same time, and the browser can do as much as the bandwidth allows. Here is a case from Misguided. It's a UK retailer again. So if you have nine files, 9 CSS versus 1 combined, you can see it on the network side. Basically, the load time is more or less the same, very similar. On the bottom, combining is a little bit faster. But if you render, the browser always has an overhead on processing each separate file. So combining many small files for the browser in terms of CPU and effort is much faster. So if you are combining small files, keep doing it. Right? So if we go to JavaScript, the results were very similar. H2 was the winner in most of the cases with many small files. And what about rendering? So we had an example where we put 1,000 div styles, and we have different JavaScript files that it will apply and change the color of each style. And you can see in H1, they start getting applied. And more or less, it takes 3.9 seconds. And the H2, you can barely see the red color because they all come at the same time, and the JavaScript gets applied at the same time. So at the end, H2 is faster, but the rendering is a little bit different between the two. If we do the same thing again with JavaScript, combining, in this case, 4 JavaScript into 1, you can see the network. On the network, it's basically the same, but rendering in this case is better. And if we see an example on a real website from a Belgian friend, you can see that combining the JavaScript, they have several benefits. Apart of the overhead gains that you have, also you can load them asynchronously in an order. So if you have the 4 JavaScripts and you load each one asynchronously, you don't know in which order they are going to load. However, if you have it all in the same file, they are going to run in the same order, right? So the summary for small files, H2 is very efficient for many small files. However, browsers, they have an overhead problem, so it's not always better. Just don't rely on the protocol just to take care of the small file problem. If you are combining files today with H1, don't undo it. Keep doing it as you have. And it's OK to put a few files out of the files that change more often. It's OK to put it out of the bundle. And then in that case, you can purge it and do things that cache with different settings. So you can some benefits on that. Right? So we're going to sprites.
Yeah, cheers. So same question really with the small files that we did with CSS and JavaScript is what do we do with our images, and do we create sprites, do we use them or not? So there was a lot written when I think H2 was being designed around, yeah, we don't need to do this stuff anymore. So again, we did a very similar experiment, and we wanted to delve in and say, is it actually true? Should we use sprites? So again, as we saw in the previous examples, pretty close results between the browsers here, but now it seems to be mobile Safari doesn't like lots of images. Interesting that, dealing with images, obviously browsers are doing different things, and now Chrome is one of the slower browsers to load these, which is also interesting. So again, let's take a look at the individual browsers. So this is interesting from Chrome, is the difference between H1 and H2 is pretty similar, but one thing for sure is clear, that the smaller number of files you have, the better it is to load these images. And like I said, the difference there is pretty small between the two this time, but I think we can just about see H2 winning, which is good. Firefox, as Javier said, now for some reason H2 in Firefox doesn't seem to be as quick as H1 was in June when we first ran this, or May when we ran the results. But again, these are really, really close. But also, the same message here is true, is that we can see that it is faster to load these files when we have smaller numbers of files, so having sprites seems to be a faster way of loading the page. Mobile Safari. So yeah, it kind of started off well, up to about 100 files, and then we could not get any good data, and obviously I ran these over and over and over. Same message, though, with kind of like what we were seeing up until the point it broke, which was small number of files is better for performance. So what was the issue with mobile Safari? Essentially, this is what we would see in the waterfall, was a bunch of timed out failed requests. And it was hard, obviously, as you know, debugging in Safari is not quite as easy as debugging in Chrome, but it could be the same issue that we're running into an issue with maximum streams. It could be the TCP buffer. It could have just been memory and CPU on the device. Don't forget, on web, so we were using the real iPhone 5 in the Dulles node on web page test. So it was a real device, and maybe there was just too much requests going on that the actual device seemed to fail. So it's pretty hard to say, but like I say, if you are thinking about breaking out all your images and not serving a sprite, then don't go too big, and definitely test it on Safari and make sure it's OK. This is the mobile Chrome version. It's had a bit of a mixed bag here. H2 is kind of faster at the beginning, and then as we got up to a lot of files, then H1 seemed to be a little bit faster here as well. So a bit of a mixed bag. So again, as we've kind of mentioned already, these tools, web page test is great for running experiments, and it's great for digging in and debugging. But if you are running this on your website, then you really need to kind of use web page tests to run your experiments, but then use RUM to do your real value confirmation, because it's your real users that we care about, but actually you'll see how H2 is performing in the real world. Same thing with the visual experience of loading images that Javier pointed out with JavaScript. It's not just how quickly it loads on the network. H1 on the side here, you can see started rendering a lot earlier, but H2 finishes a lot more. So like we talked about at the beginning, if you've got images that are a little bit more critical, more important than the others, then try and break them out, because otherwise you lose control of when they're going to load, and they start loading slower. So with sprites, it's not just about loading time. I think we need to consider a couple of things. So the first one is the management complexity, right? It requires more time and effort to actually work with a sprite. Now, we have tools to help us do this, but we shouldn't ignore the fact that it is a lot easier just to put an image on a page and manage that image on its own. We should think about caching. How often do those images change? If you're changing one of those images every week and you're breaking the cache for the other 99% of that sprite, then we're not necessarily getting the best out of our caching performance. And as I mentioned just then, how many images are you actually using on that sprite? I'm sure all of us could probably do a little bit of housekeeping on some of our sprites and tidy up images that are maybe, or little icons that are no longer used. And are you actually using all of the images on the sprite on that single page, or is it one sprite that covers all of your website? So here's an example from the Nespresso website. Now, this is a kind of typical sprite. It's got about 40 different images in there. Now, personally, there's a lot of stuff here that you can do in CSS, and you'd probably argue that you shouldn't be using a sprite to do some of these things. There's some gradients and curved edges and things like that. But if we ignore that fact and have a look at how this performs. So first of all, over the network, as a one single image at the top, it actually loads a little bit quicker than loading 40 separate images. So even over the network, there's an advantage to having a sprite. But then let's address the fact that we covered earlier, which is, do we use all of the images on that sprite, and at what point is it quicker to load those images? So for this particular instance, we have the sprite in orange, and then you can see for 1 file and 5 files, it's actually quicker to just load the individual files. And then when we go above 10, it's quicker to load the sprite. So again, bear in mind, like, have a think about how many images you're using and what works best for your website. I've mentioned here the code. We should consider the coding overhead of loading sprites. Now, it's not massive in this example. You have to have the X and Y coordinates. Technically, we're using an image in a background, which is probably not ideal either. So, you've got some kind of things to think about there, but it's not a massive difference in code. Although, again, I was in the Amazon talk before this, and when you're serving that many volumes or that much volume of code or content every month, then actually maybe a couple of lines here and there would make a difference. So what do we need to think about with sprites? First thing is keep using sprites for performance, especially on mobile. If you're only using a few images, then files are probably OK. Think about the management overhead and the cost. Think about the frequency of change of all of the images and the icons in that sprite. But also bear in mind things like mobile decoding times. And if you are only using a few images on a sprite, then don't load the whole thing, because on mobile, that's going to have an overhead on how long it takes to process that image itself.
All right. Thank you, Michael. So in a summary, most of the time, H2 improves the performance. So don't give up if it doesn't. Try and measure really, different browsers with the different conditions, with the different network latencies and geos and so on. Anti-patterns aren't anti-patterns. There have been many talks in the last year about it. And the best is if however you are doing it today, keep doing it. Many small, you have to do small work to just use H2. So if you are doing chart, it's fine to do it. Just ensure, if you can ensure the critical elements of the page, the JavaScript and the CSS, they are loaded within the same domain, that will improve the performance because you don't have an extra TCP connection and you can benefit from the priorities of the protocol. If you are combining files, keep doing it. There is no need. Browsers, CPU, and overhead, it's better. So the savings on the CPU and overhead are better than the ones that you get through the header compression. And if you are using sprites, as Michael mentioned, just keep doing it if you use enough of those images. If you have a huge sprite with many images and you only use one, then it's maybe better to just load that image. And everything, you have to remember the H2 protocol is pretty new. It's a little bit over a year old. And they're still changing, web servers, proxies, web browsers, and everything is evolving a lot. Where we saw with the Firefox example and the Chrome, one was faster than the other. And 6 months later, it's totally opposite. And I'm pretty sure in 1 month it will be again different. And also many of the problems that H2 has, which are basically because of the TCP, underlying TCP protocol, may change if we go to UDP. So there's been a lot of talks on the ATF working group, and also a few companies, like I think Google is, for example, delivering YouTube and other things, HTTP2 over quick. So this is something that we may see in the short future, hopefully. And I wanted to say something. If you want to learn more about HTTP2, there is a book coming from O'Reilly. So the book is already finished. We are just finishing incorporating all the review from everybody. There are a few people here to submit feedback, so thank you. So it will probably come December or January. And it's around 160 pages long. It covers everything, all the implementations from web servers that support H2, all the proxies, CDN, web browsers and the main difference, debugging tools, how the protocol works, and etc. So yeah, if you want to read, yeah. I have one copy, if anybody wants it. The first one coming here, I have one copy. And for the second two, I have a T-shirt. OK. To finish, as a summary, it's very easy to turn H2 today. So just do it. you are probably not going to lose anything, but most likely you will gain performance. You don't need to undo anything, just try it out. If you use one of the CDNs, it's just a checkbox, or it maybe is used by default. And one thing that you have to do, just don't blindly turn it on. Test, experiment, share. Experiment, and then whatever you learn, share with the community. Come to a Velocity talk and share your results with everybody. And so if on an average we have like a maybe 20%, I've seen in customers between 5 to 25 is some benefit we've seen with people who enable it. If you have a page that is 5 seconds and you save 1 second, and you have 50 pages a day, how much time can you save by just enabling HTTP2 in 1 year? All right, anybody knows? It's like a little bit of a riddle. How many hours can you save in a year if you save 1 second per page? Anybody? You get one book?
Tell me.
4 almost. Anybody else? No? Between 6 and 4. 5. All right. So what can you do in 5 hours? You can watch a movie, you can watch a soccer game, and do a boat tour in Amsterdam. All right.
I was going to say, so what about if we save 5 seconds per page?
So if you save 5 seconds per page, then you have much more time at the end of the year. It's 25 hours. And in 25 hours, what I could do is I could run the San Francisco Marathon. I ran the marathon once. Then I could take a flight from San Francisco to Amsterdam. And then I will rent a car and we'll drive to Munich and celebrate Oktoberfest. All right? So that's all the savings you can have. Just try HTTP2, give it a chance, and enjoy the free time. All right? Thank you very much. So
we've got time for some questions. We've also got, like, as Javier said, do you want to give the book out to first question, if anyone's got a question? Oh, there's one, like, in the middle at the back there. And there's one over there.
If you could hold your hand up, or... Oh, over there, sorry.
Are we out of time now?
We have 2 minutes. Yeah.
Hey. So one of the things I'm curious about is the issues you saw in Safari on mobile, because we turned HTTP2 on for Sky Vegas website, and we saw a number of image loading issues that we had Mac streams timing out. And we've pinned this down to an issue in the 32-bit builds of Chromium between versions 51 to 54, but we couldn't replicate that in 64-bit. So that's still open with Chromium at the minute. I just wondered if you'd seen similar sort of things yourselves in Chrome?
Do you want me to take this one? Yeah, so the answer is yes. We had some issues as well running the test when we were using the synthetic throttling in web page test with Chrome. It really didn't seem to like playing with that, but then when we turned it off, it worked a lot better as well. So it was quite funny as well. When we did this test the first time for Santa Clara in May, Chrome was failing horribly, and I emailed Yoav and said, like, buddy, what's going on? And he was like, oh, I don't know what you're talking about. Rerun it, like, test it. And I sent him all the screenshots of the issues, and then it had been fixed. And then when we reran it again this time, I started to see some of the issues coming back in again. So I don't know what those issues are. Your best bet is to speak to someone like Yoav and actually speak to him about those things. But there are issues, so test and be careful.
Or I think the Chromium, there has a blog where you can post questions. Yeah. There's a forum, yeah.
Cool. We've got 30 seconds. Is that no? Yeah.
One more question?
While we're waiting, we had these images books on our stand, and the stand is now closed. If anyone wants one, come and get one. There's a whole box down here. I don't want to have to carry these home, okay?
So I was wondering if you would try to extract the critical CSS from inlining it in HTML into a separate file and then push it first, that should, in theory, of course, increase the speed because we could, in theory, cache it, but we have no caching and pushing. Are you guys thinking about, for instance, implementing some sort of caching cookies into Akamai so that you could really gain a benefit out of this?
Yeah, so you can, for example, do today certain things with the Akamai. I mean, I don't want to do this very Akamai-centric, but yeah, but basically, for example, one of the problems of pushing is that avoid pushing things that are already in the cache. So one thing you can do today is put some logic on the server side, and I say if there is a session ID, it means you already visited the website before, so don't push anything. So if there is no session ID, push something. And regarding the caching of things, you know, we are very active on the cache digest protocol, and we'll see if we can. The best is when the first time you contact a server, you tell them what yours in the cache, so you don't have to send anything extra. So that's the goal of.
Yeah, I think that's the ultimate goal, right? But right now we're dealing with kind of workarounds and hacks, and I think what Javier said around like detecting yourself that someone's been there before, and then maybe changing your pushing rules or something is something you can do. The other thing is we've got like the automated pushing stuff as well, but right now, as far as I'm aware, that will just keep pushing, and it won't have any recollection of whether you've been to the site before. But it will be something that we're looking to add, I'm sure. So.
Yeah, and the best push is the adaptive one. So depending on your network conditions, your latency, and which browser you use, you push more or less.
Yeah.
So that's the ultimate. But it's, you know, the best work is the one that requires more preparation. Cool. Yeah, thank you, everybody.
Thank you.